Hello, this is Idle Cruise. I noticed something strange. Also near South Georgia Island on the Scotia tectonic plate. This other thing looks like an impact crater on the Atlantic plate, and it seems to have been obscured by the Scotia plate itself. Then I was reading about the mysteries of the Australite strewn field made of one-of-a-kind tektites. I looked up a picture of the strewn field and found that it almost matched the trajectory I imagined it might have been involved with the crater. I noticed my estimates of the position of the center uplift and the general trajectory was not right at the known origin area between New Zealand and Australia. Then I realized that if the debris was from an impact thousands of miles away, it would not be moving with the rotation of the Earth like other objects and would land to the west of its original target. Some rough estimates show the original target area starting about 4,800 miles away and landing about 65 degrees west of that for a distance of 4,800 miles, but 5,500 miles over the moving planet. The difference of 65 degrees accounts for 4.3 hours, and the distance of 4,800 miles would make for an average speed of 1,116 miles per hour for the objects landing closest to their source near New Zealand. Keep in mind the field covers 10% of the Earth. NASA says the button-type Australites had an entry of nearly horizontal and at a speed of 6.5 to 11.2 kilometers per second. If my theory was close to being accurate, this difference might be explained by saying NASA findings are from the exit, and the return into the atmosphere was at near free-fall speed. The second bit of information relates to the tectonic plates themselves and the rate and placement of the subduction. The whole of the north side of the Scotia plate does not have the Atlantic plate in a state of subduction under it, except in the area that this crater seems to sit. Did the crater cause the subduction? Is the rate of subduction matching to the approximate 800,000-year Australites? If we make a circle around the rim of the crater, its peak seems to land just south of St. George Island shelf area. It even appears the crater has helped form the material for the uplift that creates the island. Just by looking at it, the distance obscured might be from till and subduction, and seems that it is approximately 40,000 to 80,000 meters into the crater. So, over 800,000 years, that plate may have changed its course a bit and even its rate of movement, but for now it seems to look like one of the slower subduction areas in the rest of the Scotia plate is only moving slightly slower than the Atlantic plate, both moving west relative to Africa. The slower Scotia plate is causing them to move towards each other about 8 millimeters per year. That plate, some plates move up to 120 millimeters per year. I'm not sure of the subduction rate, but if it correlates with the 8 millimeters per year, it would move 64,000 meters in 800,000 years. These rough estimates seem to be closer than I had expected. If this is an impact and did cause a subduction in that area, then it would make sense that it landed right near the border of the plates and thus began disappearing within tens of thousands of years, if not instantly became part of the mantle below the Scotia plate. Also, at 340 miles in diameter and not destroying all life, might mean it was created by a larger, fragile, or volatile object that fused with the crust, unlike other asteroids or comets. Australites are unlike all other asteroid debris fields. I'm not saying crystal spaceship. I'm just showing a picture of it. Hope you like my first video. Hope to make more soon.